Hello, welcome. This is a talk about wetware coding, which maybe sounds strange because you usually code software. That's true, but when you're learning how to code software, you actually have to learn how to change your wetware because you're going to be using a language you've never learned before. So this talk is about how to do that with a specific emphasis on something called chunking. Chunking is actually something that comes to us from psychology. It was discovered in the 1960s by someone named de Groot. At the time, it was believed that grandmaster chess players had this phenomenal ability to just magically memorize many chess positions very quickly. De Groot discovered that they actually did so by chunking very important features about the game into one sort of single chunk in their mind. What I'm highlighting here is what grandmasters call the pawn chain. Now, I know this is not a talk about chess, but I want you to understand the psychological concepts from their roots in psychology. So we're actually going to test our own brain's memory when it comes to chess in just a moment. So I'm drawing the chain of pawns here. This is 8 pieces connected into one, and it has a kind of shape to it. You can kind of see the contours of that. There are 3 in a row here, 3 in a row there, and then there are 2 that are off the row. One is right in front of the king, and the other is right in front of the rook. Altogether, though, that makes a single chain with a particular shape. And it's symmetrical, almost. On the white side of the board, we have a similar looking chain. It's actually almost exactly the same as black's chain, but just with one pawn being different. Now, the point of this is actually that the human mind is somewhat limited. We can't keep very many things in mind at one time, 7 plus or minus 2 things. There are 8 pawns on both sides. That's 16 already. So that's way too many. But if we think of it as 2 pawn chains and then just a couple extra pieces, like the knight and the bishop that I just put orange squares around, and then this other knight over here, well, hey, that reduces the number down to somewhere within that range, 7 plus or minus 2. So if you're going to memorize this position, which guess what, I'm going to ask you to do in just a minute, you could just remember the pawn chains, sort of. You might not get them exactly right, but to sort of look at their shape. They have a kind of geometry to them. So there's those 2 pawn chains with their shape, and then there's 3 other pieces, 2 white pieces, a knight and a bishop, and a black piece, a knight. So that's altogether pawn chain plus 3 other pieces. Now the rest of the pieces are in their starting squares, which if you have played chess, then that's a chunk for you because you've set up the game like that many times. You don't have to remember every single piece and where they are separately as a single entity, a single chunk in your mind. It's just one chunk. It's just pieces on their starting square. Now, if you haven't played chess, that's not a chunk for you because you haven't memorized it. So it's just a matter of what in the past, what important features have you committed to memory. So I recognize that this activity, what I'm about to ask you to do, which is to plug in this exact chess position on this website. Don't worry, I'll show you the position again in a moment. But I'm about to ask you to remember a chess position, and I know that that's going to be different for everyone. Some people have more trouble with it than others, and it's just a matter of your past chess experience. But either way, just since this isn't actually about chess, it's about chunking, you're still going to learn something about your own mind, something about how easy or how hard it is to remember certain features of the visual perception of the chessboard. So take a look at it right now. Try to remember it. Look at the structure of those pawn chains. Try to remember where those knights and bishops are. Think of them in relation to each other. Just a few more seconds without me talking. Okay, whoever's running this activity, pause the video. Everyone go to this website and do the best you can. Remember, this isn't about learning chess. It's about learning about yourself, about your own wetware. So pause the video for 5 minutes. And don't worry, I'm not going to make you memorize this one. Even grandmasters couldn't memorize this one. This is what de Groot discovered in the 1960s, is that when a chess position doesn't have the common features about it, the ones that grandmasters expect to see, like a pawn chain or pieces, in places where it makes sense, then it becomes very hard to memorize. These random positions with things, even like these pawns that are on this row, if you've played chess, pawns can't even get to that row because they can't move backwards. Two kings, they're next to each other. That's also something that just can't happen in chess because there's a rule that says that kings can't move into danger. So, of course, they can't move next to another king. So randomness is extremely hard to memorize because our minds just can't make sense of it. We can't chunk anything. So when you're learning how to play chess, much of it is learning how to see the board, how to see the chunks, how to know what the big features are, how to know what the structural features are. That is the insight that de Groot gave us. Now, to start relating this to coding, let's look at something that's a little more like code than chess. Let's look at English text. This is Shakespeare. Actually, this is code, and this is Shakespeare. But they have similarities to them. They're both composed of letters. They both have punctuation in them. They're both, in this case, roughly the same length. But there is a major difference with English. Mainly that with English, we read it linearly, word by word. Tomorrow, and tomorrow, and tomorrow creeps in this petty pace from day to day. Code is absolutely not linear, necessarily. It's more about its nested structure, what is inside of what, which we'll get to in just a moment. Just want to kind of give a teaser of that. Now, the thing is, that the reason that's important is that you can actually use rote memorization to remember English text, and it's not that bad. Actually, actors do it all the time. The reason is that the text matches on to what we would say. So it's okay to say, tomorrow and tomorrow and tomorrow creeps in this petty pace from day to day. Tomorrow and tomorrow and tomorrow creeps in this petty pace from day to day. Over and over and over and over, and it will stick in your brain, and you'll memorize it, and that's actually okay. Nothing wrong with that at all when it comes to English text. But it is not how you would memorize code. In code, you would have to chunk the structure of the code differently. So let's try that now with English text. Even though we could use rote memorization, I just want to introduce a different way of thinking about how text is structured, because we can port those insights over to looking at code in just a moment. So just humor me for a moment, and let's memorize this not in a rote way, but in a structural way. First, I'll observe there are 5 lines here. There are 5. So that's an important chunk. That means if you try to remember this, even if you don't remember any of the actual lines, at least you can write down, even if you write down not 5 lines of nonsense, that's still structurally close to what this text actually is. Now, chunk number 2, let's make this entire first line a chunk, because it's pretty easy. It's the same couple of words repeated several times. So Shakespeare made that one easy for us. Tomorrow and tomorrow and tomorrow. So there are 5 lines, and the first one is easy. That's 2 chunks so far. Our third chunk will be context. What play does this appear in, and why? Well, it appears in Macbeth, and I won't spoil Macbeth for you, but it comes out of someone's mouth after they have received terrible news about a death of someone that they care about, and it has made them descend, at least in this moment, into complete nihilism, complete loss of faith in life. That context is what makes all of the words make sense. They're not just words stuck together. They're not just grammatically correct words. They are words chosen very specifically to evoke a specific emotion at this specific time, which answers the question of why. Why are these words being spoken in this way right now? We'll see the same thing with language in a moment, where these particular words, this particular code is the way it is because it's inside of a language called lang adventure. We'll come back to that. But context is everything in code. Every piece of code is in some context. That context dictates the structure of the code, and it says why that structure is the way that it is. So 3 chunks so far. We have that there are 5 lines. We have the first easy line, that there are 3 tomorrows. And we have the context of the whole thing. I'll just write sad to help us remember that chunk. Now let's start breaking down the rest of the lines. This next one starts with creeps and ends with day. Then we have to and time, and fools, and the, and candle. Now, again, I know this is not how you would normally memorize this piece of text. Rote memorization would work just fine here, but bear with me. I'm trying to show you a different way of thinking about breaking down the text. So it creeps day, to time, and fools the way. So you can actually use rote memorization, just not on the entire text, just on sort of like an outside-in structural understanding of the text. So I'll make that the last chunk. Creeps and day, to and time, and fools, the, and candle. So what I'm trying to get you to do is memorize this out of order, non-linearly, structurally, which means you don't have to write everything in the order it appears. You can skip them until the end. You can write the structure first and then fill in the insides. You can write the text outside in with an understanding of the overall structure. That is much closer to how you should look at code than your intuitive way of reading English text. But you can do it with English. There's nothing hard about it. So I want you to do that now. I'll give you a few more minutes to try to memorize this soliloquy. I won't talk, but then it's going to go away, and I'm going to ask you to write it. Okay, go to mytextarea.com and see if you can write this soliloquy non-linearly. Okay, it's time to actually look at some code. And I'm going to do it the same way that we looked at chess and the Shakespeare passage, which is not to necessarily talk a lot about what it does or how the computer thinks of the code. That's all for later. That's for after you've learned how to chunk what you're even seeing. So chunk number 1, this is lang adventure. That means everything in this text is dictated by the fact that it is in a particular programming language, chunk number 1. So when you write this down later, if you forget everything else but remember the lang line, that's fine. That's the most important thing. Now, these parentheses, they always match, just as you would expect parentheses to, and they dictate what the nested structure of code is. So we would say that this part that begins with basic avatar, is inside of the part that begins with adventure game. So I'll do this one in red. Basic avatar. So this is a chunk of code right here, denoted by parentheses. And it is inside of the larger chunk. So we've got chunks within chunks. It is inside the larger chunk that begins with adventure game. Here's another one. It starts with page, and it ends right here. It's also inside of another chunk, one that starts with basic cutscene, which I'll highlight in purple. So basic cutscene, that's got a chunk right there, and it encompasses the chunk that says page. So there's this larger one on the outside that starts with adventure game, and then there are the other ones on the inside that I've highlighted already, like basic avatar. Learning to see this structure, that is critical to learning how to code. Just learning how to see. Just as if you were learning to play chess, you would have to learn to see the pawn chain. Same thing. So here's another chunk. We're in lang adventure, and the first biggest chunk is the one that starts with adventure game. So that's chunk number 2. Chunk number 2. Now inside of that, there is another chunk that starts with basic avatar. And once again, you don't have to remember everything inside of that chunk number 3. You don't have to remember Pirate Girl Sprite or Speed 20. I mean, you can if you want to. If it happens to stick in your brain, you can. But for this exercise, where I'm going to ask you to try to remember this code, you don't have to get everything. You just have to get something about the structure. So we'll make chunk number 4 basic cutscene. So we have 4 chunks so far, and then I'll add a 5th one, which is page. So as long as you remember what's inside of what, you're structurally looking at the code the right way. So if you remember that in a moment when I take this away, great job. You do not have to remember 100% of this code. You just have to start to get the structure right. So let's do it. Let's try it. Let's jump right in. There will be plenty of exercises like this today. So I'm just going to give you a few seconds without me talking to look at this code and try to remember it structurally. Okay, whoever is running this activity is going to pause the video right now, and you're going to open up Dr. Racket and try to type in just as much as you remember. It doesn't have to be everything. Okay, this next part is kind of choose your own adventure. It's up to whoever's running this activity. If most people got that right in the last exercise, go on to the next part of the video. But if it seemed like people were struggling or a lot of people got it wrong, that's okay. Just go back, let them see the code again, and give them another chance to train their wetware. You can do this as many times as you like. Okay, let's do another one. This is also Lang adventure. So chunk number 1, again, that should be easy to remember now because you just did it. But the code here is different. The rest of the code is not exactly the same. So I'll point out one part that is the same, but there's also an adventure game chunk, just like before. And you can just remember that because it's in Lang Adventure. This is a programming language for making adventure games. But here's a new chunk up here, and it starts with define. Define lost cat. And with the amount of training you've already had for your wetware, you should immediately be able to detect that there's a chunk inside basic item, is what that one starts with. Here's another one, starts with list. Note it comes after the word dialogue. Just note that. Here's another one, it says fetch quest. Now, I'm not going to ask you to remember this one, but I want you to look at it as if you were going to. So put your brain in that same cognitive state of where you are absorbing this text structurally. I'll stop talking for a moment so that you can do that, and then we'll start the next exercise. Okay, it's game time. Whoever's running this activity is going to pass out some cards that'll help you speed up your vision. Your vision, that's how quickly your eyes see what the structure of code is. The cards that you're going to see are going to be hexagon shaped, and they'll have some code on one side with parentheses. And they'll have another side too that has basically like an English description of what that code does. And you can feel free to look at the English if you want, if that'll help you memorize the code, that's fine. But the main thing I want you looking at is the code side of the card. Getting truly fluent in coding takes time. But one of the marks of fluency is how quickly your eyes dissect the code and make sense of it. It takes just a few seconds for me to say parentheses tell you where the chunks are. But that doesn't make you fluent in coding. You have to see it fast. You have to train your wetware to see it instantaneously, to look at code and just understand it. And I know that if this is your first day that you've ever tried to learn how to code, then it might feel like it's going to take forever to get there. It might seem like everything's just a soup of textual chaos, but I promise that you will. So be kind with yourself. If you remember 1% of the code, that's fine. Just test yourself again. Maybe you'll get 5% the next time. If you're disciplined, maybe you'll get 10% after that, and so on. Eventually, you'll get to 100%. And not just on one card. You'll actually be training a skill where you look at a card and then you understand 100% of it right away. That's how you speed up your vision, through exercises like these. Whoever's running this activity can pause the video now and give you a few minutes to do this challenge. I want to point out one other way that you can look at the code, which is that this define chunk actually defines something called lost cat. And that lost cat actually gets used later. Now, what define lost cat is, well, it's a basic item named Milo, cat sprite, but you don't have to know any of that. What I want to point out is that it matches. It gets used inside of the fetch quest chunk. So chunks can be inside of other chunks, but they can also be linked to another chunk by the words inside them. So lost cat links those two chunks together. An analogy would be that this part of the pawn chain isn't just any part, it's the one in front of the king. There's a relationship there. So noting that relationship can help you remember which part of the pawn chain is further forward. In this case, it's the pawns in front of the king. Likewise, it's not just any chunk that uses lost cat, it's the fetch quest. And that matters. So that gives you another relationship between chunks. And relationships between chunks of information are also chunks of information. The more chunks of information you have about a piece of code, the better you understand it, hands down. Okay, it's time for the last activity of the day, creative time, where you're going to take some of those same cards that we gave out before, but this time you're going to see what you can change. Anything inside of quotes you can change, like you could change, can you help me find my cat? See what that does. You're going to type it in, change something, and run it. You could try changing adventure game to something else. Maybe it'll work, maybe it'll break. And that's important to remember. So it doesn't actually have to work. You're just being creative. You're finding things that do work and things that don't. So you're going to take those cards, just like before. And let me give you one other idea for something that you can do during creative time, which is you can take two cards and you can try to combine them inside of Dr. Racket into one program. That's essentially taking two games and putting them together. That is something that we call synthesis. You don't have to do it. It's just an idea. So the point is to be creative by either changing things, you can try breaking things, or you can try synthesizing things. It doesn't really matter, as long as you're being creative, as long as you are experimenting. Okay, pause the video for this last activity. Thank you for being here, and thank you for being willing to learn. Feel free to ask any questions you want of whoever is running this activity. All in all, though, I hope you enjoyed this talk about how to code your own wetware, how to improve at the ability to understand the languages with which we code software.